For our next session, we're going to have a fireside chat with Jordi, who's one of the co-founders of Polygon, and he worked on the Polygon ZKVM. We're going to talk about all the things that he's interested in these days and what he thinks the future of this world looks like. So without further ado, please welcome Jordi. Hey, Jordi.
Hello.
We've been in a lot of these talks before, and every time we do this, I get to learn something super interesting from you, and you end up sort of teaching me about something that I didn't even know was a thing. So I'm excited about what I get to learn today. And we'll kind of just jump right in. I mean, I'm curious about where a lot of your time is going these days.
What I'm doing these years?
Yes.
Mainly I'm focused in zkISK. I mean, zkISK is... we are very much a team that did all the prover of the zkEVM. We have been evolving for these years a lot the technology that's behind the zk there. And since the last year, we have been building a zkVM, not EVM, but VM. I mean, a generic something that you can build Rust programs, compile, and create it. The main goal of zkISK is so we just took out this technology and say, okay, how much can we push this technology in order to optimize latency instead of optimizing cost? I mean, costs were relatively low in the...
And this is in comparison with the zkEVM or
Exactly.
Just the normal VM?
In the zkEVM, well, the first challenge was just to build, to be able to prove. But after we were able to build this, we were trying to reduce the cost. I mean, cost and efficiency, cost and latency a lot of times goes together, but until some point, okay? And then we just optimize for cost, okay? But we realized that, for the aggregation layer, but also, for example, Ethereum for in the bean chain for protocols. I mean, if you want to, you are going to need to build proofs fast, even if it's a little bit more expensive, but you need to build them fast. If you are able to build a block, to prove a block in 10 seconds is much better than if you do it in 1 minute, and if you can do it in 1 second, it's better than 10 seconds. And all these protocols, so in this technology, is going to be fundamental, and this technology that's able to build that fast. That means is, and then it's just, okay, you need to redesign like a lot of pieces, taking in account all this. And that's why we built all the protocol. We divide the proof in many subproofs that's highly parallelizable. We optimize the execution part that you cannot parallelize that much, but we optimize that so that you can extract the minimum part that's not parallelizable so that you can go really fast on that side. We optimize all the aggregation. When you have all this proof and you want to aggregate to a single proof, we have to optimize. So we were thinking with a single target of optimizing
latency.
The latency. Okay? And well, I think we are getting very good results. We are very much at proving in real time. And yeah, we're going to announce next week some amazing
this is awesome.
results. Yeah.
I guess when I hear that you're optimizing for faster latency, usually this seems like a mix of software optimizations, but also hardware. How much of this is kind of coming in from you just making a better compiler, or kind of really having an opinionated piece on like how proof generation happens, versus we're just going to throw more machines at the problem and also do some of that optimization on software?
It's teamwork.
It's more about like understanding like where is the inefficiency right now, and where did you have to spend most amount of time?
One of the things that, for example, I would put, so one of the key pieces that we discovered very soon that was quite limiting is the execution part. If you want to prove execution, you need to execute that. That's quite obvious, but it's, and if you are using RISC-V, that means that you need to execute that in a RISC-V or something that's emulated in a RISC-V. And that's not enough because you want to prove it. So you want to execute and get some trace, some minimal trace or something so that later on you can build the proof, okay? So, if proving a block, it takes in a processor 1 second, that means that if you are emulating and instead of going to 2 gigahertz, you go to 100 megahertz, maybe it takes 20 seconds, so you are already out of scope on that. So we had to optimize RISC-V execution in Intel. So one of the things that we did is we just did a kind of a transpiler. I mean, we take an instruction of RISC-V, we convert to instructions of Intel, and we are running in assembly, adding whatever is needed in the RISC-V. So this is, for example, this gives us a huge improvement. At this point, for example, we are like, we are running RISC-V execution at 1.5 gigahertz. Okay, so we are, which is, compared to the 100 megahertz that the, other
It's
teams.
a pretty big improvement.
It's an important, and this is one of the pieces. Okay, the other is that we optimize. Another piece is the aggregation. We have a lot of proof. You want to aggregate. Because aggregate, if you divide that in 1,000 proof, that means you need to build a kind of a tree of that. Okay, and every time you need to aggregate them. So you need to, and then at the end you have log n. Whatever time it takes this aggregation. If this aggregation, it takes just 1 second, you have 1,000, log n is 10, so it's going to be 10 seconds already there. And if it's 2 seconds, it's going to be 20 seconds, this aggregation. So here, we just took all the techniques that we learned from Plonky 2, and we even went a step further, and currently we are about 100, 150 milliseconds in the aggregation part. So that means that all the aggregation takes less than 1 second, 1 second and a half altogether. And the other is all the parallelization. It's okay. It's a multi-server and it's a cluster. We're using. It's not a supercomputer because we don't have requirements of bandwidth, but it's a cluster of servers just computing that. And this also has a lot of synchronization things and ways to produce that. It's a lot of work. It's a lot of work from people. We also have we are also using a lot of the work. Actually, it's interesting because we were not using it in the, we're using a lot of work that we did for optimizing in GPUs. We were not using all this code. This is work that we did together with supranational people. We spend a lot of money in Polygon in optimizing that part. Something that we didn't use it because it was not optimal from the cost perspective. Because it was
cost to compute or just
no, we were able to build proofs faster with GPUs, but the cost of the GPU, because you had to put the GPUs in there, the overall cost was much higher, so the cost per proof was higher. But now that we are optimizing latency, this is super helpful because this goes super fast, and then at this point, it's much, we see that putting a lot of GPUs makes a lot of sense, and it's faster and cheaper, okay? So we are reusing all that. It's a lot of the learnings, and not to mention all the learnings on the security things, all the bug bounty that has been running the zkEVM or having the zkEVM online. We learn a lot of the things that can go wrong, the things can go right. We rebuilt all the PIL language, all the language that for the arithmetization. We did a full rebuild so that all the errors is multi-error. So that you can have this multi-system proof. There is a lot of innovations and a lot of small pieces that we are putting together in this.
That's awesome. And I guess just to confirm, this is what I'm hearing. It's not just like ideas; these are actual implementations happening that you get to actually optimize and see till the end, which is even better. It's not just a prototype. I do have a bunch of follow-up questions there, but I'll skip those for now. And I want to talk about something that you brought up yesterday with me, which was obfuscation. Tell us about what that is and what makes it interesting.
Obfuscation. Yeah. Obfuscation is, can we say, is like the next ZK? It's a new technology.
Yeah. So the next hot thing is not ZK. Is
maybe it will take 10 to 20 years. It's something that's not ready. It's something that's, let's say, it's at the research level. But yesterday, and actually I want to give awareness of this technology because it's really a technology that I really believe that's possible. Of course, it requires a lot of research and requires some years, but it solves a lot of the problems that currently we have. With this technology, for example, you can build a Bitcoin bridge between Ethereum and Bitcoin without forking Bitcoin at all. And quite a straightforward. We can make, with this, for example, we can make that DAOs or smart contracts just do real signatures, straightforward. we can do, I mean, any multi-party computation can be done in a single, very easy, in a single step. I mean, we can do.
I guess maybe at a high level, like what exactly is this as a concept, and what exactly is being
the concept at the end
simplified?
So the concept at the end is you have a program, I mean a deterministic program, and actually you are obfuscating that program, you are encrypting that program, you are compiling that program. But it's a compilation that you cannot do a reverse engineering. I mean, you just compile, you can execute things, but if you are trying to get what's inside, you cannot learn anything. I mean, it's cryptographically encrypted.
And this is you talking about the fact that the program itself is obfuscated, not just what data it's manipulating is, which is different than FHE.
Well, actually, it's, so the program is obfuscated, but actually the trick is, I mean, the important part is not that the program is obfuscated, is that in this process of obfuscation, actually you generate the key. But it's a key that nobody knows. It's a key that's embedded in this obfuscated program. The program can use it. So in the case of a Bitcoin breach, actually, I mean, this key, the public key of this key is the key when you will send the funds. And if when you are executing it, if you are proving, for example, via ZK verify that you burn some funds in Ethereum, then this program would sign using his private key, so that it's doing the send back to the Bitcoin. I mean, it's like, but it's, you have this idea that you have
a better guarantees about what should happen. Yeah.
It's again, I mean, this is something that is not possible now, but it's.
But we know it's possible, or we know
that's possible. So
okay,
we know that's feasible. So it's actually, I mean, there are some protocols. The problem is that I think that obfuscating these programs takes like something like 2 to the 27 years. I mean, it's a good start,
but but so we know we can get there. It's not. We haven't proven that it's hard.
And what I've seen, I mean, I've been researching a lot on the last month, and what I've seen is that, I mean, there is only about 10 people in the world doing real research on this topic, which is, I mean, it's crazy. I mean, it should be much more for the importance of this technology on that. And this is a little bit as that. And I see that there is a lot of ways to attack this problem. I mean, from different places that has not been explored enough. I mean, I think that there is, it could be much more effort, and I'm sure that it can come some good results. In the last paper, for example, is something that's about local mixing. It's something that's already broken, but I mean, they are trying to fix. I mean, it's in the research phase. But all this, for example, comes from the physics. I mean, it doesn't come from the cryptography research. It comes more from the physics research, especially for the supercomputers. I mean, the kind of reversible circuits and all that. I mean, it's a kind of physicians are proposing something that's obfuscation. And this opens a new way of facing the programs. But I'm sure that there is other ways, I mean, maybe from coding theory.
If enough people are spending time on it, I'm sure they get to optimize.
Well, I think it's super worthy to invest more in this base tech, especially because the importance, I mean, what you can get with this technology is huge in the crypto space.
I mean, I can't wait to see over the next, I guess, decade. Seems like this evolves. It does kind of unlock a whole new way to think about trustless execution, right? And
I mean, for example, one thing is private blockchains. I mean, very much what Aztec is doing, but I mean, we went with states that nobody knows.
To still manage two different states for public and private.
It's trivial. I mean, if you have these technologies straightforward, I mean, you solve that in a single shot. And even you can do that for example, you can run a rollup, a layer 2 on top of Bitcoin. Even I mean, it's
a lot unlocks because you don't trust your intermediate anymore.
Bitcoin has a little problem is that it's not really final. I mean, there is a difference with Ethereum, and the fact that's not final. This adds some limitations there, but you see, I mean, it enables a lot of nice
creativity, I guess. How do you think about decentralization, I guess, moving forward? We're seeing so much stuff around real-time proving, centralization on execution. We're thinking hardware acceleration, kind of coming to proof generation. We have well, I guess not obfuscation here, but just I guess real-time proving has made a lot of this opened the box for a lot of this discussion, and everybody's trying to optimize for latency. So now if I have to do sub-second transactions and have to let anybody still create a node, does that change the nature of what decentralization means?
Yeah, I mean, if you want real decentralization, you need this technology, okay? And this needs technology to be fast, safe, and this is where, I mean, where the current effort is for the decentralization is. I mean, in the space, I'm a little bit disappointed in how the space it is. Maybe it's because, I mean, I'm quite maximalist in the decentralization. And
ideals are good to have. I don't think you have to apologize for that.
But I mean, I think that L2s are not enough decentralized, and I'm talking in general. Probably that's because the market is asking. Maybe it's not asking for this decentralization.
They're rewarding the behavior that kind of goes against.
If you're telling, if you are telling to application, what do you prefer, 20 milliseconds final block or being full decentralized? A lot of applications are going to tell you usability and 20 milliseconds. And well, this is a balance that sometimes you have to take, and maybe decentralization is not taking enough weight. So the market at the end is who decides a lot of times. So these L2s providers, I mean, they do what the market realize. But it might hurt. I mean, I've seen that if we don't add, if we are not using the real value, that's the decentralization in the systems, then we are not going to be much different than Web 2 or that other systems there. So improving decentralization is a must, is something that we need to think, even sometimes if it costs us a little bit of adoption, but I think that keeping the values is important.
I guess what values do you think are missing or not being fully satisfied?
Well, I mean, for example, right now most of the rollups have centralized. They have
on the sequencing or
centralized sequencer. That's an example. But all of them, they have some sort of multi-sig. I mean, sometimes I'm joking. I mean, the fight was between optimistic rollups and zk rollups, and we end up all being multi-sig rollups. I mean, it's that's the end result of the fight. Okay, so which we are going a step backwards. This is, I mean, we need to remove multisigs. We need to add forced transactions. We need to add decentralized sequencers or base sequencers. We need to think in censorship resistance. We need to think in, I mean, for example, even a sequencer with a forced transaction, for example, it's more decentralized because actually they cannot censor you, but they can kick you out of the network. I mean,
they can just not give you the RPC endpoint key.
You want to be universal. I mean, you want to have networks that that people cannot kick you out. They cannot steal your funds, but they can make you that you cannot use the system. So thinking on these values, I think, is important.
So is it that you think it's just not moving fast enough, or you think people do not care? Because we are seeing a lot of base rollup experimentation. We're seeing people kind of try to prototype these things, and is a disappointment that it should have happened sooner, or
it's
or by your metric, you don't think that's where the focus is for people at all?
I think it's both things, and the problem is that one thing is connected with the other. I mean, if the users don't ask, then the interest for developing these technologies is less, so the investment is minor, and then it goes slow. And if it goes slow, you don't get this, so you are not going to sell something that you don't have it. Okay, so I think it's connected, one thing or the other with the other. If we have more demand from the users, then it's going to be more pressure.
It's going to be prioritized, yeah.
So that's the thing. I mean, in Polygon we are seeing, I mean, there are things that I would like to do, and it's like there are other priorities. I mean, maybe it's more worthy to do something that goes faster, and that's something that's more safe. I mean, it's about priority thing, and yeah, this is real debate.
Actual trade-off of like, I guess, in a way being a business to some form. Do you have any advice for rollups and other L2s to kind of, there's so many that are still going to come up, and now it's even easier to start one. Like, what do you think that founders should think about as they're experimenting with more L2s, whether it's more aggregated layers or ZK or OP?
I mean,
like how do we correct this? Other than just saying people just need to do this and hoping that they do.
I think that any founder should trying to build something in this space should think. I mean, should do the comparison. I mean, what happens if I'm doing this in this space or I'm doing that in a normal Web 2 way? I mean, what's the differential part? Because a lot of times, I mean, depending what you want to build, what you want to do, you're going to do it much better if you're just doing a normal server with SQL, whatever. I mean, if you are going to do a decentralized server, seriously, I mean, consider doing. There are great tools for doing centralized services that work very well. Okay, so if you are going to do a Web3, it's why you need to think why you want to do it in a Web3, why you need a decentralized thing, and I mean, how much decentralized needs this to be, and what decentralization is enough for your application.
And how do you measure decentralization here? Just the ability to not be censored, or that anybody can participate, or something else?
Well, you need we're talking decentralization. You need to go to all these values. I mean, I would include even here, for example, privacy. I mean, that's something that sometimes we talk about. But I mean, have a set of values, censorship resistance. I mean, it's that. The system keeps working, how many decentralized people you have, I mean, all the trade-offs that brings the decentralization. But you need to understand very well I mean, who can attack your system, how can you protect against attack, who can have access to the system, what's the cost of the system. I mean, you need to understand who controls the system, who's able to multi-sig. I mean, what happens if these multi-sigs just collide together or they kidnap
There's
together?
A lot of compromise.
All this you need to understand. You need to understand what's enough and what's not enough, and this is going to be different. I mean, if you are doing an application for governments, you will have some requirements. If you are doing an application for voting, you are going to have some requirements. If you are doing an application for I mean, some governance of a DAO, you will have another requirements, and you need to understand these values, because when you understand these values, then you will be able to select and to select, I mean, the full stack that you are building. And this is important. I mean, the stack is, I mean, you get the worst, okay? So that's why it's quite important that the bottom layer, I mean, Ethereum needs to be super decentralized. It needs to be, the core values of Ethereum are not negotiable. I mean, it's because...
Do you think right now it's not, or...?
I think right now it's not negotiable, and I think Ethereum...
No, or is it not decentralized right now by your metric, or...?
I think that the level of decentralization of Ethereum is, I mean, it's perfect. No, probably could be much better, but it's... I mean, it's much better than, for example, that Solana, or it's much better than...
I guess it comes down to what you're comparing it to, but
yeah,
yes.
And probably it's much worse than Bitcoin. Okay, so it's not, but having a core, I mean, if we can do it better in decentralizing Ethereum, I think we need to go for it, because this is will set the decentralization. I mean, you are not going to be, if you are building something on top with rollups, with whatever, you are not going to be better than in this layer. When you are putting a rollup, then, okay, here you are restricting more. Maybe it's a centralized...
So you inherit the base layer properties, and it gets worse every time you go up.
So do not expect to build something on top of a rollup that's this already is very much centralized. So rollups needs to have a lot of decentralization. So this stack, all the stack that you are running, you need to analyze this stack and see if this stack, I mean, it's okay for your specific application. And if you understand that, I think it would be easy to choose which is the one. Together, of course, with other properties that you may use. I mean, usability, the liquidity that you may have in the space. I mean, it's other factors. But I think this is an important one you need to take into account.
Amazing. Well, looks like we have a lot of things to think about if we're in the L2 ecosystem. But as always, Jordi, it's amazing to hear your thoughts on what you think is going to change the world here. And thank you so much for the conversation.
Thank you very much.